Okay, today we're going to learn about the commutative property of multiplication. So we've already learned about the commutative property of addition. Now we're going to focus on multiplication. This is 1.5 part 2, page number 12. So we're going to identify and apply the commutative property of multiplication. Remember, the word commutative comes from the word commute, which means to move. So we've already identified these terms and these factors and what they mean, so we're going to be using these as we get into the formal definition. So in Schoology, you can go ahead and define the commutative property of multiplication as CPM. You can go ahead and simplify it as that. And this property states that changing the order in which factors are multiplied does not change the product. Changing the order, changing movement. Okay, we're focusing on movement with these properties. Changing movement of factors. This is the key word here, factors. Remember, factors are things that are being multiplied. Does not change the product or the outcome. So if you look here, we've got the two factors, A and B. And what they're saying is if we multiply the factor A before B, that's the same exact thing as multiplying the factor B to the factor A. Changing the order that these factors are multiplied in will not change the outcome of what they equal. So if we plug in numbers for A and B, let's go ahead and say that A is -2 and B is 3. And we can simplify this to say, okay, -2 times 3, that's a -6. And a 3 times a -2 is also a -6. So any numbers that we would select for these variables would result in the same outcome. So changing this order does not change the outcome. So if we had the factors, let's say, 2x plus 3, right? If we use this commutative property correctly, this first term has two factors. Right? It's got the factors 2 and it's got a factor of x. So we can change the order of these two factors by saying, okay, x times 2 plus 3 is the same exact thing, just changing the order of these factors. And then if we had, something a little bit more advanced, let's say we had, -3xy plus 8x, right? We could say that this is the same exact thing as -3 times yx plus 8x. So we're just changing the order of these factors right here. There's actually 4 factors in this first term. We've got a -1 that's being multiplied, we can't see, times 3, times x, times y. This first term has 4 factors, right? So we can change the order of these factors however we want. So we can even say that this is the same exact thing as saying, okay, -y times 3 times x plus 8x, right? This is the same exact thing as saying, okay, x times 3 times y times a -1. Now we see that -1 because we have to, right? Plus 8x. So we can change the order of these factors however we want as long as what we're changing is being multiplied. So what happens when we're trying to commute division? That's the next question, and it makes sense. So commuting division is fairly difficult, but I'll give you an example. So let's just say we had 5x divided by 3. And if we turn this, we rewrote the way division was represented. We write it as a fraction. We say 5x divided by 3. And now you can see here we've got to take this division and turn it into multiplication. So 5x is in the numerator times, and then remember the value in the denominator under 1. So 1 goes in the numerator. So we're taking this division of 3 and turning it into a multiplication times 1/3, right? And then we can go ahead and commute the 1/3 in front of the 5x. So this is essentially how division is commuted. So if we had -2xy, divided by c, right? This is the same thing as having -2xy times 1/c, and then we can go ahead and commute the 1/c in front of the 2xy, right? So we're commuting things that are being multiplied. Let's go ahead and get into the first example. So we're providing the justification for each expression, and remember, we're focusing on movement of factors. Movement of factors, changing the order that the factors come in. So here we have 5y minus 3y squared plus 2, and the expression that we've rewrote is 5y minus y squared times 3 plus 2. So we had three terms, and then we had within the second term we had four factors actually. One factor here, one factor here, and then there's actually two y's that are being multiplied, right? That's y squared. And you can see that they changed the order that these factors came in. They've taken this y squared and they've commuted it. Since it's being multiplied, they commuted it in front of the 3. Now the 3 is being multiplied in the back. So we can go ahead and say, okay, they commuted, or they've moved the factors around. This is the commutative property of multiplication. If you look at the next example, we've got 3, that's one term, minus 4 times. Remember, minus 4 times. So this is a factor right here. Minus 4 times x plus 1. This makes up this second term. And within the second term, we have two factors. We've got a factor of negative 4. Actually, we've got three factors. We've got a factor of 4, we've got a factor of a negative 1, and we've got a factor of x plus 1. So you can see here that the order has changed. Now they're multiplying the negative 1 in the 4, the negative 4 in the back. So we could consider this to be one factor or two factors. Don't let the negative throw you off, right? So they've commuted this negative 4. It was right here being multiplied in front. Now it's behind this factor being multiplied in the back. The value did not change, and the fact that it's being multiplied did not change. So this is the commutative property of multiplication. Okay, common mistake here. Common mistake would be if you had 3 plus x plus 1 minus 4. Here, this is a non-example. And the reason why it's a non-example is because they've turned this multiplication, this negative 4 is being multiplied, into subtraction. And you can't turn an operation into another operation. That's not a property. Okay, example number 4. I'm going to go ahead and pause the video and write some steps on, so you'll see some steps in a second. So these steps are: identify the factors of each term and then analyze the order of those factors. So we're given this expression, and we've got to see if these other expressions are equivalent or rewritten using the commutative property of addition. So here we have one term, total. This is all one term. And the reason why it's one term is because we have only two factors. The first factor is negative 7, and then the second factor is all of this in parentheses, right? And then within this second factor, there's some terms, right? Because they're in parentheses, there's some terms. We've got one term with two factors. We've got a second term with 4 factors. And then we've got a third term with 2 factors. Okay, so we're not paying attention to the order of the terms inside the second main factor. We're paying attention to the order of the factors, so the order that the factors come in. So here we have our first factor, negative 7 times, now we're inside here, 4x plus 9 times 3 times x times y minus 5a. So you can see here the order is changed inside of the parentheses with this second term. The second term was 9xy times 3, and now it's 9 times 3 times x times y. So they've changed the order that the factors came in the second term. We've identified the number of factors. They had 4 factors. They still do. And the order has changed. Now the 3 is being multiplied in front. So this is actually a correct example of it being rewritten. And now we've got 4x plus 9xy times 3 minus 5a. So it doesn't seem like anything has changed inside the parentheses, times negative 7. So here's the change right here. There was not a negative 7 being multiplied back here. It was being multiplied in front. So they've just changed the order that these two factors, the parentheses and the negative 7, have been multiplied. Now they're multiplying the parentheses before the negative 7. So the order of the factors has changed, and this is also an example of it being rewritten properly. Now we've got negative 7 times 4x minus 5a plus, so we've got some change right here, plus 9xy times 3. So you can see here this third term was commuted in front of the second term. They've commuted something that was being added or subtracted. So this is not an example of the commutative property of multiplication because they commuted something that was being added. They changed the order of the terms, not the factors. Now we've got negative 7 times 4x plus 9xy times 5a minus 3. So you can see here the change has occurred right here. Now the 9xy times 5a, now they're taking something that was originally being subtracted and turning it into multiplication. You can't change the operations of things. You can only change the order of what was being multiplied or being added. You can't take something that's being subtracted and turn it into multiplication, so this is no good. Okay, now we're gonna actually fill in the proof with the expression and the justification. And so what you have to do here is you've got to look to see, okay, what's the middle expression that can get us to the third expression. And you can see that the third expression was rewritten with the commutative property of addition. So we know they commuted something that was being added. So if you look at the order to decide what's changed, right, you can see very clearly that there's been change inside the parentheses. And then you can see that there's been change with the factors of the first term. These factors have changed as well, right? And so the factors, a times, right, they're factors because they're being multiplied, would be commutative property of multiplication. And then the change within the parentheses looks like it's the commutative property of addition. So that's the commutative property of addition. So we've got to focus on the multiplication that happened first. So we can say that they commuted the factors, right? And if they commuted these factors first, what would it look like? We would type in time, or parentheses, xy plus d, close parentheses, times a, we don't need to put any symbol between them, we know they're being multiplied, minus z. So now they've commuted the terms inside, right? And they've gotten to this expression. Now we've got to figure out the next one that comes. So you can see, all right, what have they changed about this? Well, they've changed the order of these terms right here, this term right here, right, and this term right here has changed, so the order of the two terms has changed. And then they've also changed the order of these two factors right here. These two factors are now being multiplied in a different order. X is being multiplied behind the y now. So now there's two options. First, we can commute the factors. So we can say, okay, they took d plus and they changed x times, or y times x times a minus z. And then they took the minus z term and they commuted it in front to make it a negative z plus, which would be the commutative property of addition, right? Or you could have commuted the terms first. So you could have said, okay, they took this negative z, they added it in front, and then what they did was they commuted the multiplication. So this could actually be CPA and then CPM. Two different ways of going. Okay, last example today. And I'm going to do this one very, very quickly. Sorry. So I'm going to identify what's changed. The order of the two main factors has changed. They're multiplying these parentheses in a different order. The order of this factor right here, this negative 2x, has changed. So they've changed the order of these factors. And then the order of the terms, 3a and 3b, has changed. So the first thing is the commutative property of addition. That's the changing the order of terms. This is the only order that changed. So the first one would be 4y minus 2x times a plus 3b. And then here we can write two different ways. We can first write, okay, they changed the order. They wrote a plus 3b times 4y minus 2x. And then the last thing that they did was they changed the order of this, which would be CPM. Or I can go the other route and say they changed the order of this first, and then they changed the order of the two terms.